Hello, everybody. My name is Waylon, and my work that I will be presenting on today is on modeling TCP congestion with tropical algebra. And more precisely, I built a network simulation package to simulate network traffic with a discrete event simulator. And I also programmed a prior model for TCP congestion in tropical algebra, and I validated this model and identified key assumptions and some improvements. So moving into it, there are four primary key assumptions. There are three here that I was able to suggest improvements to, but one is the granularity of the definition of a packet size. The other is the missing initial delay term in the model. So these new formulations are improvements upon the model. The model is slightly different than these formulations. And then also the model works actually quite well for a single TCP connection where a packet is traveling from a source to a destination across some links in some routers in sequence. Now, we want to extend this model to multiple TCP connections. This would be incredibly useful to doing different types of forensic network analysis. And so here we provide some theoretical constructions of adapting the parts of the model to account for multiple TCP connections. Now, let's look at some of the results of the error of the simulation. So all of these graphs are plots with two TCP connections on a T-bone topology. On a single TCP connection topology, there's absolutely no error, so the graphs are a little less interesting. So in this first one on the control, we have the packet sizes of TCP connection alpha and beta are the same. And we can see that one of them clearly just wins the race condition and has absolutely no error. And the other one has error proportional to the size of the packets in the first one. Now, this is about what we would expect. In these results, we set the packet sizes of alpha equal to 2 times the packet sizes of beta. And so we can see here, for alpha, we actually processed half as many packets as we did beta. And this actually makes sense. This is expected. For this run, we actually randomly sampled the exponential distribution for our packet sizes, and the results actually vary drastically here. In this last data, we actually alternate alpha between 1/4 of beta and 1/3 beta. And we can see that alpha actually processed a monumental amount more packets because of how much smaller the packet sizes were. So this does make sense. All of these are the error between the actual traffic and what the model predicted in multiple TCP connections. Thank you so much, and thanks for listening.